Here we go. So today, this is our first geometry lesson, right? First thing we're going to learn is this. Please don't forget this, because this is going to be on your state test or your finals. You know, you get this question a lot. Okay, so we're going to use the undefined terms. And there are 3 undefined terms. Can somebody guess what they are? Yes?
Points, line, and plane.
That's right. So in geometry, we do not define these 3 terms. Point, line, and plane. Okay? Yeah. And we accept them as intuitive ideas, so we do not define them. So on the test, the thing they'd like to ask you a lot is, what are the 3 undefined terms? And we all know what they are now, right? Point, what? Line, and plane. Correct. Write this down. I'll give you time. All the other ones we define, okay? But these are 3 terms. Because they're so intuitive, right? We just accept them as what they are here. Before we move on, so what's a point? Can somebody, okay, we don't define it, but can somebody describe what a point is? So it's an intuitive idea, right? Something that comes to you naturally. What's a point? How would you describe a point? Sort of hard, isn't it? What's a, that's why we don't really define it. What's a point, guys? Point. Dot, okay, dot. Okay, so like on a line, you know, the dot, right? On a line. Oh, you could talk about in terms of 2-dimensional space, right? And maybe x comma y, coordinate point, right? Coordinate, or maybe in 3-dimensional space, you know, point. Okay, it's sort of hard. What about a line? What's a line? You all know what a line is. Okay, so how would you describe it? Yeah.
So moving point of moving path of a point.
Moving path of if you say that, then what if it's kind of curvy and stuff? Then, yeah.
The distance between 2 points.
That's distance between 2 points is not really a line, is it? I know what you mean. Like, okay, yeah. What about yeah?
Connecting 2 lines. No, 2 points.
Connecting 2 points. Okay, sure. You connect 2 points and you go infinitely to opposite direction, right? You could say something like that. Okay, to describe it. You all know what a line is. What's a plane? What's a plane? Yes, sir.
A flat surface.
Flat surface
In
that.
the area of space.
Right. It's a flat surface that goes on forever in every direction. Is that right? So you could imagine a plane going through maybe through our ceiling, right? But it goes on forever. It doesn't stay as a rectangle, does it? It goes on forever. Or it could be you know, walls or something. Does it have to be horizontal and vertical only, the plane? No, it could be in any angle you want, right? It doesn't matter. Yes, very good. You get that? Any question? Does this make sense? Okay, good. Now, all the other terms, we define them. Okay, so there are 3 undefined terms. Again, what are they? I'm telling you, it's going to be on one of your tests, okay? Because they always like to ask you that. What are the 3 undefined terms in geometry? Okay, anyway, let's move on. So some of the defined terms. First thing that we're going to define, and you will find that when they define things in books, they try to be really, really careful so that when people read it, they don't have different sort of idea. You know what I mean? Once they read the definition, they should just have, you know, everybody should be on the same page. You know what I'm talking about? If it's sort of ambiguous, it's really not good, right? So they try their best, and that's why they use certain words to describe some of these. So how would you describe space? What do you think? Anybody have an idea? Now, these are defined terms, unlike the undefined terms that we just talked about. Space, the way they define space, you all know what a space is. Can somebody just describe it for me? What's a space? When we say space, yeah. Huh? Yeah, just it's kind of hard, isn't it? So the way they describe it is they just say this. Simply, set of all points. They just say set of all points. Okay? It could be talking about, it's talking about 3-dimensional space, right? Set of all points, right? You can think about space. This is how they define it. Set of all points, right? If you have all points in this 3-dimensional space, that's what space is. Set of all points. Okay. So write it down. I'll wait. Second term we're going to talk about, we're going to define, is collinear points. What are collinear points? Hint, hint, look at what's highlighted. What do you see in collinear? What word do you see in collinear? Line, okay? So anybody have any guess? You kind of learned this already. Didn't you guys learn this in intro? If you think back. Let's see, 1, 2, 3, 4, 5, 6. How about, yeah, over here. What do you think? Yeah. Oh, collinear points. What are collinear points?
Points that are like. Same.
That are same? No. Don't all points look the same? They all look.
Yes, I guess.
Yeah. You want to add something to that? Collinear points.
It's like.
Let me give you a hint. Points that are on
Same line.
the same line is correct. Okay, so exactly. So collinear points are nothing more than points that are on the same line, on one line. Okay. So look at these points. Do you think these points are collinear, guys? Yeah. So I wasn't really careful, but yeah, if I was being really careful to put those points on that line, yeah, you see that these are collinear points. Are all lines collinear? I'm sorry. Are all points collinear? So if you have random bunch of points, are they always going to be collinear? No. What do you think we call these sort of lines? Look at, see these lines right here, the black ones? Yes, sir. What do you think? Non-collinear is correct. Very good. So they're not collinear. So non-collinear points. We call the points that are not on the same or one line, we call it non-collinear points. Okay. All right. Coplanar points. Okay. What are coplanar points? By the way, I highlighted plan there. Anybody want to guess why I did that? Yeah, what do you think?
Points that are on the same.
Exactly. These are points that are on the same plane. We don't have that E there, but these are points that are on the same plane are called coplanar points. Okay. Are all points coplanar points? No, not necessarily. Next term we're going to define intersection of two figures. How would you define intersection of two figures? This one's kind of interesting. Well, let's think about two figures that are kind of simple. What about intersection of two lines? What do you get? Raise your hand if you think you know. Intersection of two lines. One person, 2, 3, 4, 5, 6, 7. When the two lines intersect, what do you get? Yes, sir. No, intersecting. Yeah, right. Okay, so we described the whole thing as intersecting lines, right? So what is the intersection then of the two lines? Hold on. Wait, somebody said it. What do you think? Oh, you said it? What is it? Point, right? A point. So you're right. When the two lines intersect, you get a point, don't you? So how then would you describe not only just two lines, but two figures? It could be a figure that looks like a triangle and a circle, or a rectangle and a rhombus. Or yeah, what do you think? It's what? Is it always a line when two figures intersect? When the two lines intersect, you don't get a line, do you? You get a point. So how would you describe this? Well, book does it kind of, yes? Intersection point. It's not, it could be not just point, it could be some, does it have to be always a point? Think about it. When the two circles intersect, well, it could be a point, but it could be also 2 points or something. You know what I mean? So the book kind of cleverly defines it this way. Intersection of two figure is the set of all points that are in both figures. Think about it. When the two lines intersect, look at that point. Isn't that point on both of the figure? Right? When the two circles intersect, wouldn't that intersection, right? Those are a bunch of points, right? It happens to be 2 points, right? Wouldn't that be, 2 points that are in the both figures? So this is how they cleverly define them. Okay? What about when the two rectangles intersect? How many points would you get? Intersection of points. It depends, right? What if the two rectangles are right next to each other, right? Then there will be a line segment. How many points are there in a line segment? Line segment? Infinitely many, right? So that's why this is how they define it, you see? So when they define things, they want to make it as simple as possible, but yet it has to be precise, right? If they don't define it precisely, then some people may get different idea, and guess what? When they try to do problems, right, they may be on different page. Then, right, you can't solve the problem correctly. Okay, so this is what we do here. May I move on? So let's take a look at this figure here. We have a line and a point. Okay. Normally for lines we use cursive small letter, and then for a point we use capital letter. Anyway, we got a line L and a point A. So to describe this figure, there are many ways of describing this. One of the way is this. A the point A, is in line L. Okay. And is this the only way to describe this? No, you could also say point A is on line L. Is this the only way? No, there are other. You could also say line L contains point A, or you could also say L passes through A. These are all, saying the same thing. It describes the same picture. Now, why are we doing all this? It's sort of obvious. Does anybody see why we are going through all this? And, why are we showing you all this different way of describing the same picture and so forth? Anybody see the reason? Yes, sir.
Because if there's something on a multiple choice test, we'll know which one could be correct.
Okay,
They
good.
have it written different ways.
Without what?
They could have it on one problem written this way, but then on another they have it written.
Sure. Also, yes. Did you want?
When you're proving, like, you need to figure out, like, which one is right, which one is wrong. So when you're proving, you need to know.
Okay, that too. Yeah, sure. Also, when a lot of times they will give you these statements and they don't give you the figure, so you have to know what they really are talking about, right? You have to know precisely what they're talking about. Does that make sense? So they could describe this picture in many different ways, and they all mean the same thing. So we all want to be on the same page, right? If you think A is in L and you think it doesn't mean other than something like this, then are you going to get the problem right? No. Okay. So basically, that's what we're trying to do, and a lot of what you said is correct also. So that's what we're kind of doing. So we all have to be, when the book is describing something, you have to really know precisely what it's saying, right? Otherwise, you're not going to get the right answer. Okay. So what about this diagram here? We got two lines intersecting at point O. One way to describe this is this: L and K intersect at point O. So even if I didn't give you this diagram, but somewhere on your homework or on your test or on your book says L and K intersect at point O, this is the sort of picture that you should, right? Think about. Okay. Also, they could say in O also. L and K intersect in O, same thing. They could also say O is the intersection of A, L, and K. Okay. So that's another way. I'm sorry. There you go. So you could also say O is the intersection of L and K. This picture. What can you tell me about this picture? Can somebody describe what's happening in this picture? We got, how many lines do we have in this picture? 2, and we have a plane. So if you saw this on a homework or on the test, what is this describing? What can you tell me about these lines, planes, and point? Yes, sir.
The line J is intersecting plane M.
Good. That we know for sure. We know that line J is intersecting plane M at point P. Very good. What other sort of information could you get there from this picture? Yes, sir.
Line K intersects line J.
Line K intersects line J. How many people agree with that? Line K and J intersect. Turns out they don't, because you see that dotted line there. So it turns out K and J, they are skew. You guys remember skew lines? There's two lines that are not parallel, but they don't intersect. So it turns out it kind of looks like it, doesn't it? It looks like they intersect at that point. They don't really. So yeah, very good. See, that's why we're doing all this, right? So that we are all on the same page. Yes, sir. Did you want to add something?
Line K is in plane M.
Line K is in plane M is correct. What does that mean? He's right. What does he mean by line K is in plane M? Yeah.
Means that points for line K are also on plane M.
Yeah, in other words, that line is on top of that plane. Does that make sense? It's in that plane. Right? Very good. So, very good. This is what it means. So that's why this is good that we're going over this, even though it's sort of obvious. Well, I guess not really obvious for some people, because, if you think that K and J are intersecting, then you're not going to get the problem right. You know what I mean? Whatever the problem is. So what this is describing is, first of all, K and P, the line K and point P are in plane M. Okay. Also, the M contains the line K and point P. J intersects the plane M at P. And P is the intersection of J and M. Okay. So this is what it's talking about. And we know that the two lines are not intersecting because if they did intersect, right, where would that P be? It has to be on line K. Does that make sense? If the two lines were intersecting, that point P must be on line K. Because that's the only point that is going to be on M. Okay, so let's see. Now I want you to draw. This is sort of hard, so I'm going to show you how to draw it. Okay, so but first, before you draw it, what is it that you see here? What do you think this is describing? Yes, sir. Cross. Okay, a little bit more specific. Yeah. Two planes intersecting. Exactly. That's what they're showing you. Does that make sense? So let me show you how to draw it. If you're sort of not so sure. So by the way, please bring a ruler every day. I forgot to mention that on that. I think I said you need to bring it whenever I say, but have it ready every day. It's really going to be helpful. So let me show you how to draw that picture. When the how to draw a figure where two planes intersect. First, I want you to draw a line kind of slanted like this. Okay, using these lines on your paper is helpful. And then do the same, draw the same sort of line segment with that same angle on the other opposite side. And basically we're drawing a, what is this, guys?
Plane.
Yeah, plane, but using a parallelogram, right? To represent a plane. So you're drawing a parallelogram like this. And that's one plane, right? Of course, this plane goes on forever, but we can't draw something that goes on forever. Then, I want you to, on top right here, draw the same segment, sort of like that, with the same angle right up here like this. Okay, you see how I did that? And then, I want you to draw a vertical line from that end, go all the way down like this. Do the same vertical line from the one on the top, and stop right here and put dotted line from here, because it's going through that plane. Okay, it's behind it. And then go down. Don't go all the way down, because you're going to, with the same angle as on the top, you're going to draw a segment like this. As you can see, it's sort of a trick to draw a three-dimensional figure in a two-dimensional space, right? And then, of course, the intersection is going to be a what, guys? When the two lines intersect, it's going to be a? What do you get when the two planes intersect? You get a line. There you go. So that's how you draw that. Are you okay with that? Now, like I said, on your homework, when you're doing your homework, not only do you have to copy the question and show the work, I told you you have to copy the figures too, right? So if you have hard time copying them, just trace it. Put your homework on top of it and just trace it. That's fine with me. Okay. All right. Okay. So go ahead and put these, marking here. So you got plane M, N, and X, Y are the 2 points there. By the way, is this XY a line segment or a line? Is this a line segment? It's actually a line, isn't it? Because planes what? Go on forever. So even though it looks like a line segment, so you should say that when the M and N intersect, right, the XY is a line, right? It's not a line segment. Okay. Because M and N are your planes. Okay. You could also say that XY, the line, is the intersection of course, two planes, M and N. And you could also say XY is in the XY is in both of the two planes. It's sort of using that term, intersection of two figures, isn't it? Remember, intersection of two figures means set of all points that are in both of the figures. See, this line XY is in both of the figures, aren't they? So it's sort of using that definition. And lastly, you could say M and N, the planes, contain XY. Okay. Let's write that down. Yeah, no. Okay, so I want you to answer this question. Think about this. Tell me whether this is true. And I want you to discuss this with your group. When the two lines, remember your group before? When the two lines, you don't have to move the desk. When the two lines intersect, the intersection is a point. Is this always true? When the two lines intersect, the intersection is always a point. Okay, I'm going to give you time. Go ahead, think about this with your group. Think about it. Is this always true? Okay, So, how many people say yes, this is always true? How many say no, it's not? Oh, some people say no. Oh, so some of you don't agree. Okay, all right. What about this? Look, here. Don't we get 2 points? Right? How many people say this? Okay, this is wrong. Why not? Why not? It's not. Yeah, line is straight, right? It's always straight. This is not a line. It's like these are curves. Okay, so this is wrong. So when the two lines intersect, it's always a point, right? Not quite. What if there's one? Actually, there's one. What if the two lines are
On each other. In
on? Yeah. What if the two lines are same line? Here's a line. Here's the other line right here. Right? Yeah. What, say it again. It's the same line. That's right. So actually, this is what I'm trying to say. Talk about. When we say two lines, it is sort of ambiguous, right? Because when I say two lines, does it mean two different lines, or could it be two of the same line? So you see how if I asked you this on a test, if I wasn't clear in terms of what I mean really by two lines, you see how you could come up with two different answers? Okay, does that make sense? So that's why, actually, we're doing this. Please write this down. In this book, see, that's the point that I wanted to make. In this book, whenever we refer, for example, 2 points or 3 lines or 5 lines, we mean what? Two. This is sort of the hidden meaning. Two what kind of lines? Two. Hello? No, look what it says, guys. Read it up here.
different.
Two different, okay? We mean two different lines. Does that make sense? This makes it clear, right? When we say 3 lines, we mean 3 different lines. You understand? Write this down. I'll give you time. You're all writing down. Okay, so this when we say 2 lines or 3 lines, we mean 2 different lines or 3 different lines, okay? Do you see how this makes things clear, right? So for example, when I now ask this question, when the 2 lines intersect, the intersection is a point. Is this always true? Oh, it seems like people are still confused. What do I mean when I say, now after this, what do I mean by when the 2 lines intersect? I really mean there's a hidden meaning, right? When the 2, what kind of lines? 2 different lines intersect. The intersection is always a point. So is this always true now? When I say when the 2 lines intersect, the intersection is always a point, is this true? Yes, because this means when 2 different lines intersect. You see how we have to be really clear in terms of what we're trying to say. Otherwise, you could give me an answer that could be true if you interpret it another way. Does that make sense? So it's important that we are all on the same page. You guys get this? Yes? Okay. So let's do true and false. So I want you to write this down. Write down T for true, F for false. Don't say it out loud. I want you to put your thumb up when you're done writing and figure out whether it's true or false. Thumb down if you think it's false, okay? Thumb up for true, thumb down for false. So it says line PF ends at point P. Okay, this way I know that you're done writing and you've already thought of this. I want 100% participation. We will not, I want 100% of you to. There you go. PF, the line PF ends at point P. Okay, some of you are still writing. Very good. I think all of you said it is false. Did anybody say true? I don't think. This is false. You're right. Okay? Right? Does line have an endpoint? No, it does not have any endpoint. If this said segment PF, then yeah, of course, right? Or ray PF, it does have endpoint. Okay, good. What about then next one? Point S is on an infinite number of lines. True or false? Go ahead, everybody think about this. Point S is on an infinite number of lines. Go ahead, think about this. I want you to write it down. If you got the answer, show me with your thumb up or down. Okay. A couple of you said false. The answer is true. If you have a point in a space, imagine a point in a space. How many lines could go through that point? Infinitely many. Any angle, right? In 3 dimensions. Look, say here's a point right here. Here's a line. It could be in any angle you want, right? It'll go through that point, right? There could be infinitely many of them. So this is true. Do you see that? Yes, question.
Even if it can go like any way, like still, like there will be numbers.
There'll be what?
Even if it could go like any way, there only be a number amount of
No, it could be. There's no. You can't count how many lines would. Yeah. How many points are there on a line? Can you count those? No, same way. It could be an infinitely many number of lines. You could. Okay, does that make sense? Do you agree? Okay. You could put that one. Okay, so let's look at then. So I want you to think about that one, Yvette, before you go. Think about it. There could be infinitely many number of lines. So look, if you have a point, just on a not even 3-dimensional space, right? On a space, how many lines could go through that point? Infinitely many, right? It could be in this angle, but now you have 3-dimensional. You can move it anywhere you want. Does that make sense? Okay. All right, try this one now. A plane has no thickness. Is this true or false? A plane has no thickness. True or false? Think about it. This, a lot of you said true, you're correct. Right? Because you can think of it this way. If it did have thickness, how thick is a plane? Right? Plane is
10 miles long.
right. Well, it doesn't have any thickness, right? Really, because plane it goes on forever in every direction. But how thick is it? It's really, really thin. It doesn't have any thickness. Does that make sense? Yeah. Right. So it does. Okay. All right. Very good. Yeah, you guys all got that one. How about this? Collinear points are coplanar. True or false? This one I want you to think with your groups. I'll give you some time. Go ahead and talk to your group, and I want you to come up with the correct answer. Go ahead. I'll give you time. What do you think? True or false, guys? Okay, let me see. Show me. What do you think? True or false? Collinear points are coplanar. Some of you actually, this is interesting. Some of you have false. Some of you have this I don't know in the middle. This is always going to be true.
It's frozen.
I'm sorry. So think about it. If the two lines, okay, so first of all, what does collinear points mean? Points that are on the same line, right? So imagine that you have a bunch of points that are on the same line. How many planes could go through it? Infinitely many. Imagine here, like imagine that this is a line. There are a bunch of points, right? These are coplanar. And look, if this is a plane, how many planes could go through it? It could be in any angle you want, right? Infinitely many. So guess what? Collinear points are always going to be coplanar. Does that make sense? Questions? Yes? No? Okay. Oops. Okay, false. Okay. Planes. Planes have edges. Why do you suppose they actually even have this sort of question? Isn't it obvious that planes don't have any edges? Why do you suppose some people think that planes have edges? Anybody have any guess? Yes? Not so. Huh? Right. When we draw planes, what do we use to draw planes? We use parallelogram, and parallelogram has 4 edges, right? Maybe that's what people think plane looks like. No, right? It goes on forever. Because we cannot draw something that goes on forever, we use parallelogram. So, right? So planes do not have any edges, okay? All right. You wrote true on that? Uh-oh. Okay, what about this? 2 planes intersect in a line segment. Of course, this is easy, right? What do they intersect in? When the 2 planes intersect, it'll be a line, not a line segment. Please be careful. A lot of people, they don't read the whole thing. They just see this. They just go, oh, two planes intersecting a line. Oh, true. Well, it does not say line. It says line segment, right? Remember, line segment have two end, right? It's a part of a line, right? It has two endpoints. Okay, so please be careful with that one. Two intersecting lines meet in exactly one point. True or false? Didn't we talk about this for a long time? When we say two intersecting lines, what do we really mean? What is that hidden word that's there? Two, what kind of line? Two different lines, right? See, now there is no confusion in terms of what we're talking about. So this really means two different lines two different intersecting lines meet in exactly one point. True or false, class? Let me see. It is, of course, true. Correct? Okay. How about this one? Points have no size. This is sort of obvious. Does a point have size? No. If it did, how big is it? We can't tell. So this is true. Points have no size. And lastly here, can you write line XY can be denoted, means it could be written as XY with a little line symbol on top of it, or YX. Doesn't matter which order you write this in. No, it does not matter. You're right. This is true. Okay. Which one matters actually when you write these things? Yes. The ray. What about line segment? Does it matter? No. For rays, what do you always have to start with? The endpoints. The endpoints, and the arrow has to go from left to right all the time for rays. Okay, so here's an example that I did. For example, I don't have time for it. If you want, you could go watch the video, right? But and when you do your homework, I think you have enough. You have enough examples. But just in case, if you want to see that, okay. Any questions? Okay. Good.